Hi guys, welcome to the second video. It's I have to admit I had a little incident. I already recorded that video, and it turned out that I messed a little bit with the I messed it up. So I have to record it again, but I already programmed on a little bit. So it just it took me some time to when I tried to edit it. So I have to do the video again, but now there is like more data there, and so I have to so if you see some packages and some other classes that you didn't have there before, that's my fault. But in the end, it is so it is what it is. So let's do the video again. As you know, I tag the commits after each week, so you can run through the tags. And I just opened up a div on what I did between tag 1 and tag 2, which you can actually see here. And I just gonna go through this. Actually, you can do it yourself. It's quite simple. It's just git div and then the name of the two tags. This will create a div between those two commits. So I just gonna run through this list of divs and show you what I did between tag 1 and tag 2. First of all, of course, the POM. I changed the POM. It was 0.01 and now it became 0.02, like actually like this. It's different now. And what else did I do? The JetBrain annotation here, I actually specified the version because the version used to be release and it was tagged as deprecated. So I removed this tag and got the latest version. That's about for the POM. Then what did we do? What's the main theme of last week's programming? It's actually the data types. We need to map the SQL data types to the Java data types. So I created a package called data type, and you can see we have 3 sub packages: date, numeric, and text. So we have those date data types, those numeric data types, and the text data types. As well, we have an interface and an enum. So let's look at the interface. It is actually just a marker interface. So each data type is of the type I data type. And so we can have, like, if you say there is some variable or like a row, it's just an array of I data type. And we have the enum type, which is, as you can see, just an enum where all those data types are defined. And you can see here in the comments what they are, what kind of types they are. Like bigint is a 64-bit signed, which is in Java is a long. Int is a 32-bit signed, which again is an integer. Then small int is short in Java. Decimal is a float. Float is a double. The dates, all the date formats are 64-bit timestamp, and just depending on if you are want to have the date, the time, or the date time, it's just gives a different display. However, it's stored as a 64-bit value. Varchar is an array of characters, but it has to be ASCII. It's an array of char. Text I did not implement yet. Binary I did not implement yet. And bool I did not implement yet. So let's start with the numeric types, which is, in my opinion, probably the simplest. All numeric types are of type numeric data type, and this is like the base class for all numeric data types. As you can see, numeric data type implements iData type, and of course it has a logger, and we have the data type and the value of this variable. So it's a number. If you don't know number is a Java class, and it can store all the primitive data types like byte, double, float, int, long, short. Yes, and it is. I'm really surprised when I saw it. It's there since Java version 1.0. I thought it came much later, but well, that's just like my I'm sorry, but that's just my misunderstanding. So if you create numeric data type, it gets the value and the data type. The value is always set to 0. Like this value is always set to 0, not that one, this one here. And the data type is also, it's just the data type. And then you go and say if the data type is equals to big int, then we parse it to an optional with a long in it. And optionals, you probably know, it's like a container where it can contain a value or nothing, and you don't get any null pointer exceptions if it's null. So there we have those try parse big int. It's another class I created. It's there in tools, in the parser. You see all those different try parse classes. They're static. I go in there and I just tell you what they're doing. If you know C#, there is try parse. In Java, there is not a try parse. As you can see, I give it a number and it tries to get the long value of this number. And if it catches a number format exception, it returns an empty optional. Otherwise, it creates an optional with this long value. I also did one with strings because we probably need them later on, but right now they're just there for being happy around. The thing is, if you can actually use it to parse an integer or a short, because it is in Java, it widens it to long automatically if it's possible, or if it's but the other way does not around. The thing is, you should not get any null pointer or number format exceptions or any kind of exceptions trying to parse a long to a number and then back to a long again. That's the whole idea of it. So we have this in big int. Oh no, we have this in numeric. I'm sorry. Here we're going. So if it's empty, I get a warning. It didn't work, but that's it. And otherwise, if it's not empty, the value is the value. So it's not 0 anymore, it's the value. The same I do with like integer. Therefore, I use a class called tryParseInt, which works like tryParseBigInt. It's all the same. There you go. tryParseInt, optional of int value, number format exception. You get it. So this is it is a big if-else block where it is trying to, if the data type is a big int, then parse it with this class. If it's data type int, try parse it with this class. If the data type is called a small, then try to parse it with this class, and so on. And if all those don't work, the value still is 0. That's important. So we don't get an exception. We need to work on that because that's not perfect. However, we need to we don't get any exceptions. Like we should have something where we actually can specify what the minimum value is of a certain field. So if you have like a counter and you count from 1, 2, 3, 4, 5, like an ID. 0 is something you don't need, but if you, or -1, something you don't need. But if you try to store temperatures, doesn't matter if it's Fahrenheit or Celsius, yeah, you should probably might need a 0. So for the first, in this first, like trying to get it all running, we stay with 0. It's the first iteration, let's say that. Then we have a text value. I just implemented varchar at this time. Varchar is of type iDataType. I don't have a text data type implemented because it is the only one, so maybe later on we still do that. The value is a char array. If the string value is, and the max length of a varchar can be 255 characters. So if it's more than 255, actually we should put a logger there. Like let's add to do add logger for value point length bigger to 55. So that's the first thing we don't want to have. Then we create this char array with 255 characters, and we always use 255 because it makes our life much more easier in the later on when we are saving it to disk. So every varchar is the size of 255 characters, and we know each integer is one particular size, and each big int and each float and so on. They all have particular sizes, and so we can actually know exactly how many bytes a row needs. It's not variable, so each row in a table has the same the length in bytes or in bits, so we can calculate easily where the 5th, the 10th, the 100th entry on the file system is. So that's the reason why I made this varchar fixed 255 characters. All the classes have a get data type, which is like just a string where the data type is returned. Then we have the date data times. The date data type, what a word, is it implements iDataType like the numeric data type. It has 3 values actually. Well, it has a long value, which is the timestamp in epoch, it's in millis. Then it's taking the data type. Thus we need to know if it's a time, a date, or a date time. Additionally, we can specify the zone ID. The zone ID is some kind special in Java. With this zone ID, you can specify the origin of this timestamp. As a default, we are using the UTC, which is London Standard Time or winter time, not the summertime. And yeah, we can use it to calculate different timestamps, like and offsets between different time zones. As you can see with the second constructor, if you do not provide any zone ID, it uses UTC. Otherwise, it uses the zone ID you prefer. If you provide it with the zone ID, it stores it with the zone ID. You can see the data type is also like the numeric data type, an abstract class. Where we here we are. It's also abstract, so you need to implement it. The get time zone, 3 implementations, wonderful, is there for, yeah. So let's take the time, which is quite simple. Time extend date data type, like the, and we have two constructors, which are, come on, let's do it like this. 2 constructors. Once one you just give like the milliseconds. Then you call the data type constructor, and with 2 arguments, or you can have like the one with 3 arguments where the zone is provided as well. Get time is where you get actually the time. It gives you an instant epoch in millis. Then it attaches the zone ID to it, and then you have a datetime formatter, and it uses a given time pattern and returns the whole thing formatted. The time pattern is quite simple. It's an enum. Here we do have 3 time patterns, and right now we can have them in hours, hours and seconds, and hours, seconds, and milliseconds. Why I use this? Because I always struggled with like the patterns you get and on SQL databases, and if there is like when datetime, if there some databases need a T in between, and the T needs to be in how those little thingies called, those here. It was always a struggle, and you have to use it like 3 or 4 times. So if you provide patterns and you test the patterns and they work, you can easily then go like, here, that's the pattern, that's what I want to have. So we have a time pattern, we have date patterns, which are quite big. I'm not happy yet on the naming of them, but I can't use colons, I can't use dashes, I can't use backslashes in the name, or slashes in the name of the enum. So it's a little bit, it's still messy, but we're getting there. And then we have datetime patterns, and then you have like the one with the T with, and they all have the T in there. I haven't really tested them yet, though. I'm gonna tell you that. That's it. That's all I programmed in the last week. Another thing, maybe what's quite cool, is like I wanted to get all those different available zone IDs, because they're all strings. So I wondered if there is enough. So let's check them out. They're really quite extensive, actually. Look at that. Europe, London, GMT, yes, of course, CET, but then Europe, Sapporo, I have no clue how to pronounce that. Canada, Yukon, and like Israel, yes, of course, yeah. Indian, Komoro, then like those generic ones, Port Moresby. Oh my goodness! Look at all those different zone IDs, which is like really crazy. I never thought there are that many. Europe, Simferopol. Okay, where is Simferopol? Europe, Prague, yes. But okay, UTC. And Arctica, McCrary. What the heck? They really did an extensive job and finding all different time zones. Yeah, it's really a lot. So that was my video for today. I hope you like it. I see you next week. Next week we are doing like some real database stuff. We add rows to a table. I hope you liked the video. Have a wonderful week. See you next Sunday.